Packet Tracer Activity 11.5.5 Subnet and IP4 Network. In this activity, your responsibility is to set up the IPv4 addressing range for each of the two LANs as shown here. We've been given the 192.168.0.0/25 network address space in order to set up our LANs. There are a series of rules to set this up. So our first, LAN A, has 50 hosts, and our second, LAN B, has 40 hosts. It's going to say we need to create additional subnets for future expansion. Now there's a series of questions that go with this, but what I want us to do is go ahead and determine what the IP addresses are going to be for each of our items, our switches, our PCs, and our router. Now, in order to begin this, I want to walk through an example talking through how to think about subnets and how you go about breaking a larger address space into these subnets. I'm going to go ahead and move over to a small set of PowerPoint slides so that I can talk about the different subnets, and hopefully you can understand this a little better. So the initial address space we've been given is the 192.168.0.0 with a subnet mask of /24. So our network portion here is 24, as indicated by the /24. This is used for the network. So the first three octets, that is 192.168.0. These last 8 bits we can use for our host portion of this. So in this case, we have 2 to the power of 8 equals 256 addresses that we can use for our 254 hosts. If you remember that one address space is always reserved for the network and one address is reserved for the broadcast. If we drop down, if we take this subnet and we want to break it into 2 subnets, we would use the /25 prefix. This will give us a network portion of the first 25 bits. The next portion of this, 7 bits, is used for the host. 2 to the power of 7 bits, equals 128 addresses or 126 hosts. As I said before, we've used up both of the, we have to take away 2 addresses, one for the network and one for the broadcast. As we continue breaking this down into smaller pieces, the /26 now, we use the first 26 bits and the last 6. So we have 2 to the power of 6 or 62 hosts, etc., down to 30 hosts, and we can keep going down till we get to 2 hosts. So let's move on, and I want to look at this in the diagram. So here's a way that I like to teach students how to understand how subnetting works. Let's say we have this office building, and in the office building is a group of desks. So in this particular office building, if we were to say this is a /24 office building, we're saying that 254 maximum hosts, or in this case desks, can be within this building. But we could have put 256 chairs in here had we not had to account for some things. For instance, there are walls that have to be put up around the building. These walls I like to think of as the network itself. So the walls that take up a portion of our building restrict or eliminate a portion of the chair space that we have within the building. I also like to think of the hallways between the desks as the broadcast address space, because they have to be able to broadcast around the room to talk to one another and maybe broadcast to the entire group of people in that. The door into the office building I think of as the default gateway address. So in our /24 network, we're going to have 254 hosts. The network address starts off with the first address, this being the .0 host portion. The broadcast is the last portion, the .255 for the host portion, and then the gateway is the .1 portion. Let's go on to the next slide here. Now I've taken this same office building, but I've decided to put a wall down the center of it and break each side in half. So we now have a /25 network. Now, when we broke it in half, that meant we should be able to have 128 in both sides. But now we have the same problem. We've had to put a wall up between them. Now this wall takes some space away from both of them. So each have to have a network. So the network address for this side is the .0 portion. Now over here, notice that the network is the .128. Now it's not a 0, and I know this can confuse people. So what I wanted to talk about is this portion first. So we still have 100 or 256 potential addresses to use. The first 128 are going to be used for this side of our building, or 0 through 127. And that's what it shows here. The network is the first, broadcast is the last. Then the gateway is the first available after the network. The second portion of our building, or the second subnet, will start at the number directly after the broadcast address of the first subnet, or 128, and the last address, 255. 0 through 255 equals 256 available addresses. And then the gateway, the door in this case, would be 129. So this is one way of looking at it. Now if we break this down a little more, now what I've done is I've taken the second half of our building and broken it in half. So notice that I have 128 potential addresses here. I took my 128, broke it in half so that each area has 64. This way of breaking up subnetting is known as variable length subnet masking, because we are varying the way that we're breaking apart the subnets. So in this case, I broke this up. This is still 0 through 127. I then took this upper portion for the next 64, started it, the network address, at 128. The broadcast address in this case is going to be 64 addresses away at 191. The next portion will take the next 64, or start at 192, and go to 255. So hopefully this helps when you're thinking through trying to build subnetworks. Let me go back to our packet tracer environment. So now let's go ahead and try to figure out how we want to break up these two LANs. So let me take this packet tracer here, and I'm going to try to, I'm doing this wrong. I'm going to try to pull this up, and I'm going to bring a notepad in here along with this. So here are our requirements. This is our network space that we have. It says we need a total of 4 subnets. All right, so of our 4 subnets, we have 50 hosts in one and 40 hosts in another. So for me, what I like to do is I like to start off and say a /24 network has 256 potential, or 254 hosts. A /25 has 128 or 126 hosts. /24, 6, 64 or 62 hosts. /27, 32 or 30 hosts. So I don't need to go any farther here, because if we look at our number of hosts needed, we need 50 or 40. So a /30 address range, if I were to break this down so far that I only had 30 available per subnet, that wouldn't work. 62, on the other hand, allows me enough space to put 40 hosts or 50 hosts into this. It also will allow me to put up to 4 subnets. If I look at this a little differently, I could say this only has 1 subnet. This is going to have 2 subnets, and this will have 4 subnets. So as we decrease the host portion, the number of subnets we have increases. In the assignment, there are a series of questions that you'll be asked. It's important to go through these so that you'll have a better appreciation of how subnetting works at the very detailed level. But I'm going to move us down here to step 2 when it's saying fill in the address space. So it says assign the first subnet to LAN A. Okay, so we said that the /126 mask would be the appropriate one for our uses. So I'm going to go ahead and I'm going to scroll down here, and we're going to go, we'll put subnet 1, and we'll make this the 192.168.0.0/0z0. This will be the first address. This will work through 192.168.0. So we have 64 available addresses here. The number here is going to go to 63, and the reason is because we start with a 0, but there are a total of 64 addresses here. So the first subnet will have the address range is 192.168.0.0 through 192.168.0.63. We can do the rest of the subnets the same way. 2.168.0.64 through 192.168.0.127. Subnet 3, 92.168.0.128 through 92.168.0. And I don't remember, I think it's 191, but let me check. Correct, 191, and then our last subnet will be 192.168.0.192 to 68.0.255. So our subnets here that we could put in here would be, this would be for the first one. Let's see. Oh, I don't have the ability to type in here, so this is why I'm using a separate notepad here. So what we want to do here is we're going to assign the first subnet to LAN A. So this will be the subnet for LAN A. second one will be for subnet, or for LAN B. So this is LAN A, and this is LAN B. Now these two are going to be unused. Now a question might arise, why don't I just make LAN A here and then LAN B here? Well, there's a thing that you probably want to avoid when you're subnetting. You don't want to break across the section that you're using. The routers will not allow you to do that. So you're required to do them in order from the top to the bottom. So I went and opened the student version of this assignment, the Word document, and I want to go ahead and let's just go ahead and fill in the appropriate addresses here. So in our LAN A, if that were off the gigabit 0 address here, let me see if that is correct. And the first LAN A, I think that's correct. So here we'll go ahead for LAN A. We're going to make the IP address 192.168. Of course, we can't see anything here. Let me fix all that. Sorry, I took things offline for a moment and fixed that, but I'm back now. So our IP address of the router, first we know we have the network portion, but now we need the IP address. So the router is our gateway, our default gateway. So we need to put the first available host address here. So in our subnet here, 0.0 stands for the network. So our subnet, or excuse me, our default gateway will be the 1. Now the subnet mask here. So we have 255.255.255 dot what? So this is often a question. So how do I determine what my subnet mask is? Well, we do know that when we first do a subnet, it starts at 0. If I were to look at this in our, let me go back to our PowerPoint slide here and go to the beginning. So our /24 here uses all of the bits in this are 0. So that's why our mask is 0. Now here, when we've used the first bit in our network mask, or for our network out of our host portion, the first one here, its decimal equivalent is 128, or 2 to the power of 7. So 128 is indicated in this bit. If we add all the rest of these together, their decimal equivalent, that becomes 128. So a /25 network has a 128 decimal equivalent. If we go to the next one here, we have to take the decimal equivalent of this first bit and add it to the decimal equivalent of this bit. So this becomes 128 plus 64 equals 192. So 192 becomes the last portion of our network mask. So let me copy this down. So we're going to continue the same process, except I'm going to add 32 to our bit here. So this will become 224. Let's see, what did I do here? This is /27. I wrote that down wrong. So 224 would be for a /27 address. And if we come back here, we're using a /24. So what we really want is the 192. So we'll go ahead and put that as our subnet mask. So 255.255.255.192. Now let's do the IP address of the other interface for LAN B. So this will be similar to this, except it has to start into the next subnet. So here is the second subnet of our group. So we have a .64 is for the network. So this portion here is going to be 65. Now the subnet mask is going to stay the same. We do not have to change that. Of course, it's going to bother me again. Hold on one moment. Sorry about that again. Finally got it to cooperate. So our subnet mask is the same for both of these. Alright, so for our VLAN, let's see, what did it want us to make the VLAN? So we're going to use the first host address is for the router. Second host address is for the LAN. And then the last host address for the PC. So let's go figure that out. So the switch would be the next host address. So we'll make this a 2. And as normal, our subnet mask will be the same. So for our next subnet, our switch will be the next host address, or .66. And again, our subnet mask is the same. I'm just going to go ahead and continue this down. So our PC needs to be the last host address. So bring this down. So if we come down to our first subnet, our last host address is not the .63. It's actually the .62 because the .63 is for the broadcast address. So we'll make that .62. And then similarly for the other one, it'll be the .126, or 1 before the broadcast address. Alright, so that was the hardest part of this, getting the subnet information figured out and the IP address ranges and the IP addresses for each of the devices. So let's go to the last portion here, the easiest portion, and configure the devices. So let me go to the customer router here, and it's asking us to do some setup here. So let's enable the device. Go to the configuration, and then it says we want a secret password. So enable secret to class 123. And we want a council password, so we're going to go to line con 0, and then we'll put a password as disco123, and remember you have to turn login on. So let me exit out of here. So we want to go to interface gigabit G0/0, so I'll go to that one. Then we have to do an IP address for this of 192.168.0. So this is to our LAN A. Actually, let's make sure I'm using the appropriate port here before I continue. So, because I can't look at that, can I? Trying to remember, there's an easy way to do that. If I just hover over the line, it's supposed to do that. Let me just close this. Now, it's not going to let me see this. Well, we'll find out if it works when I'm done, since I can't determine. So this will be the .1. Was for our LAN A with a subnet mask 255.255.192. And then we'll do the interface G0/1. And we'll do the same thing here, except it's going to be, let me check my notes. This is going to be the .0.65 address. Oh, let's see, things I forgot about. Let me turn the interface on. And let's go back to the other interface. and go no shut down. Oops, it looks like I had them backwards, so I'm going to have to fix. You notice here that this came up, so I've got the IP addresses backwards. So this is a good opportunity for me to fix this before I turn on the other one. So let me go back to, actually no, interface G01. That is the correct one. Great, I did have it correct. So let me turn on the other interface. Alright, so we have the interfaces up and running now. So let's go back down our list. So then it wants us to, let's see, on this router, let's just do the save the running config. So we're going to go copy, run to start. See if I did it wrong. Oh, let's go copy. Oops, I think we do that one level down. Question mark. There it is. Copy. Copy. Run start. So now our router is completed. Now we're going to set up the switches. Then we're going to set up the IP addresses, or excuse me, the hosts. So let's go to LAN A and go to the command line. This will enable the switch. We need to configure the VLAN, so we'll go to int VLAN. Int VLAN 1. We'll do its IP address 192.168.0.2. 192. Okay, so we have the VLAN set up, but we also need to do a default gateway for this. So let's look at that. Okay, it's under IP, so let's go to IP and then default. And then we just put the IP address 192.168.0. Our router, the default gateway for this is the .1. So now we can exit out. So our switch is ready for LAN A. Let's go to PCA. And let's go ahead and configure its IP address. So 192.168.0.62, and we'll change that to 192. We'll put in a default gateway 2.168.0.1. Alright, so that PC is ready. Let's do the other switch. We'll enable the switch, go to the configuration, terminal level, and then we'll go to the VLAN 1, and then we'll do an IP address of 192.168.0.66. 192. I then have to exit out of this, then we'll do IP default gateway 192.168.0. Make sure we look back in our scheme. This is 65. So we'll exit out of this, and then we'll go to the PC. Give it its IP address 192.168.0.126. And appropriate default gateway is 192.168.0.65. Okay, so if we've done everything right here, we should now be able to ping the appropriate devices. So let's go to PCB and let's try to ping across to PCA. So let me close the configuration. So we'll do a ping 192.168.0.62. Let's see what we get. And there we go, just as we expected. So from PCB to PCA, we have the appropriate path constructed. I'm not going to go through all the rest of them, but I am going to go across the routers to see if I can get to the server. So let's do that. So let's do a ping at 209.65.200.240. And there we go. So all the pieces are set up correctly now. You can, if you'd like, go ahead and test your other devices to see if they're working correctly. If they're not, just go back and make sure that you've got the correct settings for those devices based upon the diagram that we've completed here. This ends this video.